Okay, so this is section 3.4. This is called general annuities. Okay, and the idea here is that we're going to use everything we've used before. So right now we have our giant formula. Okay, so over here we have AN deferred. And then over here we have A sub n. And then our regular payments start. Okay, at the time of our regular payment, that would be our AN due. Over here, when the payments end, that's your S sub n. One payment period later, whoops, sorry about that. One payment period later would be your SN due. And then way over here would be SN foreborn. Okay, so right now this is our timeline. Okay, so remember the number of payments is N. Okay, the number of periods from here to here is your P, and then the number of periods from SN. Whoops, that's wrong too. Okay, number of payments is R, and the number of payments from SN to AN SM4, that's your M, right? So those are our three variables that we're going to talk about now. So now we're going to talk about section 3.4 is all about how we deal with an annuity where the interest rate does not match the frequency of the payments. Okay, so there's four really cases that we have. So the first one is that the interest is more frequent. The second one is that the interest is less frequent and we use compound interest. The third one is that the interest is less frequent and we use simple interest for partial periods. And then the fourth one is our continuously compound interest. So our formula, we've talked about this before. We're going to use what's called the EIR, the effective interest rate, and that's 1 plus the current I to the Y minus 1. Okay, your book writes this as I sub X. Okay, so if you're looking at that, they're talking about I sub X. Okay, now your I is going to be our interest rate over the old. Okay, and then Y is the old frequency of interest divided by the new frequency of interest. Okay, so just to kind of give us warmed up on this, we're going to go ahead and do example 26A and B. So when we do 26A, what we're doing here is we're taking a semi-annual interest. Okay, so that means that our new is going to be 2. And our rate right now is 7.2%, so that means R is 0.072. Okay, and we're saying that our old here is monthly. So our old is monthly, so that's 12 times a year. So that means our exponent is going to be 12 over 2, so 6, which makes sense because there's 6 months in 1 year. Okay, so that makes our I. Here we use the old and the R to get our I. So I is 0.072 over 12. So then our effective interest rate would be 1 plus 0.072 over 12 to the 6 minus 1. One plus 0.072 over 12 to the 6. Then we subtract 1. I used the minus or the negative by accident there. So we get 3.06544, and it keeps going. So what we're going to do, okay, is that ends up becoming 0.0365 so then it'd be 3.65%. Whoops, would be our effective interest rate. 3.65%. Okay, now go ahead and pause the video and then try to find the quarterly one so you have some practice. So now you've had a chance to practice. We're going to do the quarterly part. So same process. Our new here is still going to be 2 because we're still trying to find the effective semi-annual interest rate. Our R is still 0.072. This time so that tells us that I is going to be 0.072 over 4. And that our Y, the exponent, again is going to be old over new. Old over new. So that's going to be 4 over 2, so 2, which makes sense because there are 2 quarters in every semi-annual period. Okay, so that all is connected. So then our effective interest rate is going to be 1 plus 0.072 over 4 squared minus 1. And then we can pull that up on our calculator here. One plus 0.072 divided by 4 to this 1, or sorry, squared minus 1. So we get 0.03632 or 3.63%. So again, we're rounding these to the nearest hundredth of a percent. I know it's not said so in there, but on like you're testing your homework, I would always round to the nearest 0.0%.